So here are the definitions of some functions. So start at the point, picture, 1, 0 on the unit circle. Maybe for emphasis there's 0, 0. And rotate by some angle of theta radians counterclockwise. So go forward by some angle theta. Your end location will be some new point x comma y. The trig functions, cosine, sine, secant, cosecant, tangent, and cotangent, are now given by the following rules. The cosine is exactly the x-coordinate. The sine of theta is exactly your resulting y-coordinate. Secant is 1 over your x-coordinate. Sorry, that's not always going to be defined, right? What can I not divide by? 0. So if x winds up being 0, I can't talk about secant of theta. And maybe you'll even notice, right, x is the cosine of theta, so if x happens to be equal to 0, or cosine happens to be equal to 0, then I can't talk about secant. Maybe it's even worth writing this replacement. Right, 1 over x is the same thing as 1 over cosine. The cosecant of theta is 1 over y, is the same thing as 1 over the sine of theta. And again, it's defined unless y equals 0, but y is sine of theta. So it's defined except when the sine of theta is equal to 0. Fair enough? The tangent of theta is given by y over x, also known as sine theta over cosine theta. Cotangent is given by x over y, also known as cos theta over sine theta. So by looking at the formula for tangent theta, that's not always going to be defined. What might go on? Cosine is equal to 0, then something bad happens. So if x, which is cosine theta, is equal to 0, then we just can't talk about tangent. In the case of cotangent, if sine theta, which is the same thing as y, is equal to 0, then we just can't talk about cotangent. So there are some formulas. Before we move on to this, let's actually do a quick geometric motivation for what tangent of theta means. So let's draw a picture. That same picture. So you rotate forward by some angle theta. You end up at some point x comma y. Well, wait, so I drew like a straight line in there, right? This line? What's the slope of that line?
Oh, you're saying slope, so like it would be over x.
Yeah. So it would be the change in y, which would be y minus 0, divided by change in x, would be x minus 0. The slope of that line is y over x. That's tangent. Tangent has a geometric meaning. It's the slope of a line, given the angle that you deviated from a horizontal line. So here's the point. This is the slope of a line given its angle from horizontal. Nice. That seemed pretty reasonable. And there are the geometric interpretations of all the other ones, but that's the one that I think I want to point out right now. So here are some definitions of functions. And right, all a function means is it's a rule that takes a number, in this case theta, and returns another number. And each of these do that, right? It doesn't matter that these functions don't seem to be very formulaic or algebraic. That's fine. let's go ahead and try to compute them for some numbers, just to get an understanding of what these functions mean. So here's one. So let's suppose you start at 0, 0. Nope, start at 1, 0. Rotate counterclockwise by an angle of pi over 2. What type of angle is an angle of pi over 2? It's a 90-degree angle. It's a right angle. So if you rotate forward by an angle of pi over 2, well, that puts you right on the y-axis. So if you start at 1, 0, rotate forward by a right angle, what point do you land? What point do you wind up at? 0, 1. Cool. So x is 0, y is 1. So what's the cosine of pi over 2? 0. Because it should be the x coordinate. What's the sine of pi over 2? 1. What's the tangent of pi over 2? 1/5. Yeah, so that will be y over x. That looks like it wants to be 1 over 0, but you can't do that. It's just undefined. What's the secant of pi over 2? Also undefined? Cosecant of pi over 2. 1. So that'll be 1 over the y coordinate. That's 1 over 1. That's 1. Cotangent of pi over 2. 0. People feel pretty okay about that? So,
could you move up a little bit, please?
yeah.
Thank you.
So if you want to compute trig functions, well then maybe you can just do a little bit of geometry to figure out where the point that you want to study actually lands. And once you know what that point is, you can just read off the trigonometric functions. That makes sense? So let's do some more of that. So, this time, let's rotate by an angle of pi radians. Remember, 2 pi radians is a full revolution, so this is half of a full revolution. And I think I'll talk through those first 2 blanks and then leave you guys for the rest. So if you start at 1, 0, rotate forward by half of a full revolution, what point do you land? Negative 1, 0. So you have an x coordinate of negative 1, a y coordinate of 0. Write down what all of the resulting trig functions are. Maybe while you guys do that, I'll just So, I just wanted to have those on the board for reference. So, by looking at this picture of the circle, what's the sine of pi? No, start at the actual top. What's the cosine of pi?
Negative 1.
Negative 1, because it will be the x coordinate at the end of this rotation, which is negative 1. What's the sine of pi?
0.
Good. It'll be 0 because the y coordinate is 0. What's the tangent of pi? 0. What's the secant of pi? What's the cosecant of pi? What's the cotangent of pi? So in a few days, we will do the geometry, which won't be hard, to discover that if you start at 1, 0, and rotate forward by an angle of pi over 4, then you'll land at the point the square root of 2 comma the square root of 2 over 2. Does that look like enough information to record all of the trig functions at pi over 4? Yeah. What will the cosine of pi over 4 be? Root 2 over 2. It'll be exactly that x coordinate. How about the sine of pi over 4? Compute for me the tangent of pi over 4. I hear a 1. Oh, nice. And in fact, tangent is supposed to be the slope. Does this look like a line of slope 1? Yeah, the y is the same as the 1. But maybe I'll actually write it down. So that will be y, root 2 over 2, divided by x, root 2 over 2. And maybe you would want to go through and like say, oh, there's a fraction in the denominator, so I should multiply it by the reciprocal. But I just see the same number in the numerator and denominator of a fraction, right? So I know what that'll be. It'll be 1. Let's compute the secant of pi over 4. What's the definition of secant of pi over 4?
Inverse cosine.
Yeah, it's the multiplicative inverse of cosine. And I'll emphasize that because later on we'll talk about like the function inverse of cosine. So it's the reciprocal, the multiplicative inverse of cosine. So that'll be 1 over the x coordinate. So that'll be 1 over root 2 over 2. Does that look like it should probably be simplified some? Yeah. What's the first simplification you would want to make? Yeah, multiplied by the reciprocal of the thing in the denominator instead of having it in the denominator. So you do that, and you see that should be the same thing as 2 over root 2. Does that look like a fully simplified answer? Why not?
Yeah, the square root of the denominator.
Yeah, there's a square root in the denominator. How do you get it out of the denominator?
Rationalize.
Yeah, you rationalize the denominator, so you want to multiply the denominator by root 2. So you'll multiply the numerator by root 2. And what do you get when you do that?
2 square root 2 over 2, which is just square root 2.
Cool. So the main point of that one was to make you remember how you simplify a fraction when you see some square roots in sight. What do you think the cosecant of pi over 4 will wind up being?
It's the same as 2.
It'll be the same thing. In fact, even at step 1, you see that it's literally the same thing. Maybe it's step 2, because you write down that that's 1 over y. Oh, so that's 1 over y is root 2 over 2. Oh, that's the same as above. That'll just be root 2. How about the cotangent?
1.
Still be 1? So that will be x over y. X is root 2 over 2 divided by y is root 2 over 2. Yeah, that's 1. Cool. People feel pretty good about that? So this is, if you like, the first step towards something that we'll do next time. We'll start it on next time. We'll start building just a lookup table for a bunch of values whose trig functions you just know. That lookup table is, of course, something that will go by the name of a unit circle. But let's just write down what we've discovered. So we've computed, in these previous 2 examples, the trig functions at pi and the trig functions at pi over 2. So we know those right now. Cosine of pi over 2 is 0, sine of pi over 2 is 1, tangent of pi over 2 is y over x is undefined. Cosine of pi was -1, sine of pi was 0, tangent of pi is 0. Let's try to fill in the remaining of the entries just in the first 3 columns at least, by following the instructions that you know. Let's suppose you want to compute the trig functions at 0. So, depending on how you feel, that's either like the easiest entry in the row to fill out or the hardest, depending on how you feel about 0. So let's draw a unit circle. There's the point 1, 0. So the instructions are start at 1, 0 and rotate counterclockwise by an angle of 0. So if I start at the point 1, 0 and I rotate by nothing, where do I land? Same place as I started? So 1, 0. So what's the cosine of 0? 1. Because I ended at the point 1, 0. What's the sine of 0?
0.
What's the tangent of 0?
0.
And maybe I'll fill out the rest of the columns in this row. What's the secant of 0? 1, because it should be 1 over x. X was 1, so secant is 1. What's the cosecant of 0? Undefined, because it wants to be 1 over 0. What's the cotangent of 0? Also undefined. Cool. Let's play the same game for some other angles. 3 pi over 2 and 2 pi. And that'll be as far as I'm willing to, as I'll go as far as exact computations today. So, actually I haven't done much with this picture, so let's just use this picture. So let's rotate counterclockwise by an angle of 3 times pi over 2. Remember, pi over 2 is a right angle. So let's rotate counterclockwise by 3 right angles, by 3/4 of a full revolution. So there's 1 pi over 2, there's another pi over 2, there's 3 pi over 2. Right, each pi over 2 is a quarter of a revolution. What are the coordinates of that point? 0, -1. So what's the cosine of 3 pi over 2?
0.
What's the sine of 3 pi over 2?
-1.
What's the tangent of 3 pi over 2? Cool. That makes sense? Well, now how about 2 pi? So let's start at the point 1, 0. Let's rotate counterclockwise by an angle of 2 pi. Where do you end up when you rotate by an angle of 2 pi? Same place as where you started, at 1, 0. So, what's cosine of 2 pi? What's the sine of 2 pi? Tangent of 2 pi? 0 for tangent, I think? Yeah, cool. That makes sense? So those are all of the precise computations that I'll make by hand today. But we can get some information by just kind of thinking about where an angle lives. So let's do it by example first. Let's start at the point 1, 0 and rotate by an angle of 2 pi over 3. So let's draw this. So I'll draw a few helper angles to help me out. So there's an angle of pi over 2. And bigger than that all the way around to there. That's an angle of pi. So let's try to draw an angle of 2 pi over 3 by using those to help us. So let's see, which is bigger, pi over 2 or 2 pi over 3? Which is bigger, 1/2 or 2/3?
2/3.
2/3. So that means 2 pi over 3 is bigger than pi over 2. So So here's one observation. 2 pi over 3 is bigger than pi over 2. So that means when you rotate by an angle of 2 pi over 3, you'll wind up rotating past pi over 2. Which is bigger, 2 pi over 3 or pi? Pi. So that means as I rotate around, I will not make it to an angle of pi. So I won't be able to quite make it to pi, so there will be an angle of 2 pi over 3 drawn qualitatively. What quadrant does the point at the end of that line live in? What quadrant is that? The second quadrant. So, quadrant 2. So, remember, cosine is the x coordinate, sine is the y coordinate. Is cosine of 2 pi over 3 positive or negative by looking at this picture? Negative?
Yeah.
Because cosine should be the x. So cosine of 2 pi over 3 is x. But that's in quadrant 2, the x values are negative. What about the sine of 2 pi over 3? Positive or negative?
Positive.
Because the y values in quadrant 2 are positive. Tangent? Negative. And maybe we'll write that down. So the tangent should be y over x. That will be something positive divided by something negative. Positive divided by negative is negative. Secant, positive or negative? Oh, that was like quiet, so maybe I'll make you guys either do a show of hands. So think for a second. Is secant of 2 pi over 3 positive or negative? Positive? Negative? Okay. Yeah, right. So secant will be 1 over the x coordinate. So that'll be 1 divided by x is negative. Yeah, 1 over a negative number is negative. How about cosecant?
Positive.
Positive, because it'll be 1 over y is positive. Place. So you can unpackage this into a whole philosophy of what this means. If I give you some angle, it's not an angle that you want to be able to compute trig functions explicitly. Instead, you can just ask yourself, well, this angle, what multiple of pi over 2 does it live between? If you have an angle that lives between 0 and pi over 2, then that angle will live in quadrant 1. If you have an angle that's between pi over 2 and pi, that rotating by that angle will live in quadrant 2. Between pi and 3 pi over 2, quadrant 3. Between 3 pi over 2 and 2 pi, quadrant 4. Between 2 pi and 5 pi over 2. What quadrant do you think it'll be in then? Back into quadrant 1? And maybe I'll point out, it looks like that table could go on forever in both directions. Negative numbers you would rotate counterclockwise, positive numbers you would keep on rotating clockwise. But my sheet of paper isn't infinitely long, so I've just gone 5 columns out. So we can answer questions now. In quadrant 1, is the x coordinate positive or negative? So is cosine positive or negative? Plus is easier to write than the word positive, so I'll just write a plus symbol. So cosine is positive. In quadrant 1, is y positive or negative? So is sine positive or negative? How about tangent? Positive, right, because it'll be y divided by x, positive divided by positive. Secant? Cosecant? Cotangent? You guys think you can do the remaining 4 columns? Do it, and then we'll all come together. more time before we talk? Okay. Quadrant 2, x is positive or negative? Y is positive or negative?
Positive.
So, with those in mind, cosine is negative, sine
Positive.
positive, tangent
Negative.
secant,
Negative.
cosecant,
Positive.
cotangent. Nice. So I guess I should have been writing those down too. Cosine is negative, sine is positive. Tangent is sine over cosine is negative, secant is 1 over cosine is negative, cosecant is 1 over sine, tangent is cosine over sine. Same thing in quadrant 3. Cosine positive or negative?
Negative.
Sine?
Negative.
Tangent,
Positive.
because negative divided by negative is positive. Secant?
Negative.
Cosecant? Cotangent? Quadrant 4. Cosine?
Positive.
Sine? And you can derive the rest. Between 2 pi and 5 pi over 2, cosine is positive or negative.
Positive.
Sine?
Positive.
And in fact, the rest of this column will be the same as the first column, won't it? Cool. So, with those in mind, let's use those tables to not make computations, but to make assertions about positivity, negativity. Let's determine whether the cosine of 4 radians, not in degrees today, everything's in radians, let's decide if that is positive or negative. And let's use this table to help us out. What's pi approximately? 3.14. Maybe I'll settle for 3, and if things seem ambiguous, then I'll be more careful with digits. So pi is somewhere around 3, so pi over 2 is somewhere around 1.5. So let's think about an angle of 4. Is 4 between 0 and pi over 2? No. Is 4 between pi over 2 and pi? No, because pi is somewhere around 3. 4 is bigger than 3. Is 4 somewhere between pi and 3 pi over 2? Yeah. 3 pi over 2, that'll be approximately 3 times 3 over 2, or 4.5. 4 is between 3 and 4.5. So I know, so let's write that down. Pi is less than 4 is less than 3 pi over 2. So what quadrant does an angle of 4 live in? Quadrant 3. So, by this table, is the cosine of 4 positive or negative?
Negative.
And let's see, how many people have brought a computing device with them today? Let's use that computing device, and there are 2 points of this exercise. One is to make sure that everyone knows how to take whatever device they're using and make it give them answers while walking in radians and not in degrees, or conversely in degrees and not radians. And let's try to walk it out. So I'm going to use the Google calculator, but first I'll check if the Google calculator walks in degrees or radians. What's an angle whose answer I know what it will be if I'm walking in radians? What's an angle that I know what cosine is? 0, but 0 degrees is 0 radians, so give me another angle. Pi, or pi over 2, sure. Let's compute cosine of pi over 2. If this is actually walking in radians, what answer should it give me?
Oh, pi over 2 should be 0.
0. Okay, it walks in radians. So, now that we have that, oh, actually that's okay. I want to know, though, what the cosine of 4 is. So maybe I'll give you guys a quick moment. Double check that your calculator is in radians mode. By computing, say, cosine of pi over 4 and see if you get 0. So is there anyone who doesn't know how to make their calculator switch from radian to degree mode or degree mode to radian mode? No, okay, so this is a pointless exercise. You already know these things. So let's just compute the cosine of 4. Does that agree with what we saw that it needs to be? And as a quick comment, let's say you are accidentally in degrees. I think Google will do that. You get a wildly different answer. So you do need to be careful with thinking about whether you were measuring angles in degrees or radians. Same thing, let's do 0.2. Let's try to decide if the tangent of 0.2 is positive or negative. So, without using a machine, 0.2, is 0.2 between 0 and pi over 2? Yeah, because 0.2 it's bigger than 0, but it's not much bigger than 0. Pi over 2 is like 1.5, that's way bigger. So tangent of 0.2, 0.2 lives in quadrant 1, so tangent is positive. In fact, maybe you would even want to say, well, 0.2 is so close to an angle of 0 that probably tangent of 0.2 is pretty close to 0. Let's see if any of that holds up. Third. Cosecant of 7. So, let's go through the same process. It is 7 between 0 and pi over 2. How about it there? Right, 2 pi is like, if pi is 3.1, then 2 pi is like 3.2 something, 6.2, still too small. Is, how about in there? Yeah. So, which quadrant does an angle of 7 live in? Quadrant 1. So cosecant of 7 is?
Positive.
Nice. People feeling pretty good? So I think the last thing that I want to do is I want to develop what might be called the most important fact about trig functions, the Pythagorean identity. And so the point of the Pythagorean identity is, well, if you know what sine and you know what cosine are, you already know how to find the rest of the trig functions. Cosine is x, sine is y. All of the other trig functions are defined in terms of x and y. But in fact, if you know what x is, you probably have a pretty good idea what y is. And let's draw a picture of that first. So let's suppose that I tell you that you rotate forward by some angle theta. You land at some point. And let's suppose that I tell you what this x value is. So I tell you what cosine of theta is. So you know definitely that you achieve this x value. How many different options for y value do you see in this picture? 2. That one and that one. And in fact, they're additive opposites of each other. So apparently, if you know what cosine is, you know what sine is, at least up to a plus or minus sign. And let's see analytically now why that's true. So let's go through it. So rotate forward by some angle theta. That puts you at some point x comma y on the unit circle. Now remember, the unit circle is supposed to be the circle of radius 1, right? So that means that the distance from this point on the circle of radius 1 to the center of the circle of radius 1 should be equal to the radius of the circle of radius 1. So by unpackaging that a little bit, what is the square root of x squared plus y squared? Well, that should be the same thing as, so here is the under almost no numbers for which x squared plus y squared is equal to x plus y. And let's even just see this in a single example. Let's compute the square root of, I don't know, how about 3 squared plus 4 squared? Let's see if that's the same thing as 3 plus 4, which is 7. What is 3 squared? What is 4 squared?
16.
What's 9 plus 16? What's the square root of 25?
5.
So in general, 5 is not equal to 7. So in general, this never happens. Square roots don't behave well under addition. They behave well under multiplication, but not under addition. So instead, let's think about this this way. So this is a circle of radius 1. So if this is the circle of radius 1, what's the distance from any point on this circle to the center of the circle? 1. That's what radius means. So what's the distance from xy to 0, 0? 1. Do we have a formula for distance? Nope. Who remembers the distance formula for points in the plane? That's ready to change.
It's x1.
Subtract the x's and square them, and then add that to subtract the y's and square them.
So if you want the distance from the distance between 2 points in the plane is given by the square root of the difference between the x coordinates squared. Do you think it makes a difference whether I say x1 minus x2 or x2 minus x1? Nah, because it's being squared anyway. So, with that formula in mind, what's the distance from xy to 0, 0? 0 minus x squared, so that'll be x squared plus y squared. So this thing, x squared plus y squared, that's the distance from x comma y to 0 comma 0. So there's the picture. But what's the radius of the circle? 1. So the distance from xy to 0, 0 should be 1. So what can you tell me about, so this is equal to the radius of the circle, which is 1. So that tells me the square root of x squared plus y squared is equal to 1. Everyone with me right now? So let's do some stuff with that. So that is kind of a needlessly complicated formula for what we want to do right now. Let's square both sides just because it'll make it look nicer. What's 1 squared? So I see that x squared plus y squared is equal to 1. In terms of sine and cosine, what is x? Yeah, just say it louder though. I hear whispers. You rotate forward by an angle of theta. The x value is called?
That'll be a negative.
Well, cosine can just be negative. In this picture it looks negative, but that x value will just be cosine of theta. Similarly, the y value will be the sine of theta. So that means I can take this and replace that x with cosine take this y, replace it with sine, and I'll get cosine squared plus sine squared is equal to 1. So that's the Pythagorean identity, or Pythagoras' identity for trig functions. I'll go ahead and say that if there's one thing that you should always remember about trig functions, that's it. Trig functions satisfy that cosine squared plus sine squared is always equal to 1. And let's use this to do one computation. I have enough time to use it to do one thing. So I'll tell you right now that the cosine of pi over 3 is 1/2. We'll see why that has to be true later on. But let's use that to do some computations. First, let's try to compute the sine of pi over 3. And here's how I'll do it. Well, if I take the cosine of pi over 3 squared plus the sine of pi over 3 squared, what will that always be equal to? 1. Cosine squared plus sine squared is always 1, as long as it's the same angle in both of those trig functions. So let's use that equation. I guess this is supposed to be happening down here, but I think I'll have enough space. What's the cosine of pi over 3? 1/2. That's a given in this problem. So I see that 1/2 quantity squared plus sine of pi over 3 quantity squared is equal to 1. So what will I need to do if I want to solve that for sine of pi over 3?
Subtract. It'd be a 4, subtract the 4th over and then square the root.
Yeah, this is really a quarter. 1/2 times 1/2 is a quarter. I'll subtract that to the other side, and I'll even do that as a single step. So that'll give me sine of pi over 3 squared is equal to 1 minus 1/4, or 3/4. And then I take a square root. So I'll wind up seeing that sine of pi over 3 is equal to plus or minus the square root of 3 over 4. Do you see any perfect squares under that square root? 4 is a perfect square, so I can pull that out. So I get plus or minus square root of 3 over 2. Now clearly sine of pi over 3 can't be both positive and negative. It's positive or it's negative. It's an actual well-defined function. How do you think we can figure out whether it's positive or negative? Yeah, by look at the units off to decide what quadrant it lives in. What quadrant do you live in when you rotate by an angle of pi over 3? Quadrant 1. So is sine positive or negative? So apparently then, the sine of pi over 3 is positive root 3 over 2. Is that enough information that you can now compute all of the other trig functions at pi over 3? Yeah. I mean, not in the 0 seconds I have remaining, but you just compute x over y or y over x, or whichever is appropriate. So, there's some homework assigned for today. You should look at that tonight. And try to complete these 2 remaining examples, if there is demand. We'll talk about it at the beginning of class tomorrow, because there is class tomorrow.